about that graph. I think every other graph you can be fine with. And if you try one of these at home, come in tomorrow, let me know if there was a graph question, like what goes on with this graph? This is the only one I think people might have a question on when you go home. You know what it did? At one point, it did something like this. It looks like at x equal to, I think it's 5. The graph went like this. Like this. So I'm going to enlarge this. Everyone got me? Something kept what? Going up and down as it got closer. But I said I don't put that in dash. You go, why? Because I think I could use the best software. I still think you just get a blob of ink. You agree? Well, let's talk about that. Let's talk about this scenario. Let's just talk about that graph. Because we all know about sine of x, don't we? And what's the limit as x approaches infinity of sine of x? And this will help us, because doesn't that graph do something similar? The graph keeps doing what? What's the highest it gets to? 1. What's the lowest sine of x gets to? -1. But it keeps doing it forever and ever and ever. It keeps bouncing between what? 1 and -1. Does it go to one concrete value? No. So guess what I'm going to have to put for this answer?
It doesn't exist.
Does not exist. You all agree? So this idea of something kept doing this and doing this, as it got closer and closer to something, you're like, sorry, it doesn't exist, right? So that ink blob, when you look at it, you go, is this what it means? Yeah, it just kept saying it did this and did this and did this, so it wasn't going anywhere towards one number. But that's different from this. So when this was just going, as you went towards infinity, the limit was d and e. Do everyone agree? But what about a graph like this? We won't give it a name. But how about this graph? What if the graph did this? I'm just going to enlarge it. What if it did something like that? So it kept going like this, going like this, going like this, but it kept getting tighter and tighter and tighter, that number. Oh, well then we could say at x equal to, let's say, 10, as it was approaching x equal to 10 from the left side, it was approaching, I'll make this up, say like a 5. Okay, in that case, then we won't say d and e, because we can tell that it what? It was oscillating, but the oscillations between the what? The amplitude, going up and down, kept getting smaller and smaller and smaller and smaller and smaller, and it was getting closer to that. Does that make sense? That's what I just wanted you to see out of that. I didn't want that to bug you. Okay, what other graphs do I have to do for the end of class? Because I said I only go up to graphing today. Well, there's still some graphs. You're like what? You ready? Absolute value functions. Anyone know how to graph those? All right, you ready? Yes. Brilliant. V's. But what if? So I knew you all could do the V's, and very good knowing that. And when he knows the absolute value graph alone looks like a V, like this graph right here. Next one is. And we're not going to do that limit because I think you'd find it too easy. Find the limit as x approaches some number on this. Well, that just, first of all, it's continuous everywhere, isn't it? Do you know where this V hits the x-axis? Just set that equal to 0. Where's it hit? Right at 2. Cool. Awesome. So I don't think I should ask questions on this one. I think you'd always get it. It would just be the answer. The final limit as x approaches the number. You're just going to look at the number because it's all continuous, right? Like right there, here. I just think it's going to be too easy, so we're going to pick a harder problem out of the book. Final limit as x approaches 2 of that function right there. Well, I can see it. It's approaching what from both sides? 0. Oh, wait. So we got to put the y value down. So I'm glad you brought that up. As we approach 2 from both sides, we always report the y value. So what y value was it getting closer and closer to from both sides? 0. Does everyone see that? Cool. So we're like, okay, that's too easy. I'm doing a problem like, if your author stuck this in 2.3, it should be back in 2.2, because we want to look at the graph on this. We're going to look at this problem. If it's odd, I know it's an even problem, everyone, so that's why I want to do it. I actually put this in, I thought it was a good practice problem, but it's even, so we can do it. X approaches 6. 2x plus 12. the absolute value of x plus 6. Let me make sure I copied that right, did I? I think so. Yeah. So after this, I think we should do a trig graph. Do something numerically, and that'll be it. But we should do a couple of these. So here's what we have to do. Because it's in a fraction, one of them is the absolute value bars, the other done. We got to tear this thing up. All right? So we're going to tear up this graph. Well, one way to do this is you're like, well, I can use my graphing calculator and graph it. Isn't that true? You absolutely could. Does anybody know where the ABS button is on these calculators? I go to catalog, hit second 0, just if you're curious. The second 0, what's it show? ABS, right? But I would like to show you what this looks like. So we're really going to kind of hit this thing a little bit algebraically too. So I'm going to go back to, what did I have up right before this? What absolute value function?
X minus 2.
You and I have to do a little pre-calc review. And we got to talk about how can you write that expression without the bars? Does everyone remember this? Don't worry if you don't. Might have been at least a year since you did this, right? I write x minus 2 down. Then I write x minus 2 again, but I put a negative on this. Okay? I put the word if. I put the word if. I can define that absolute value function in two pieces. It's called a piecewise function. And this is, look, I'll put an equal symbol. This equals these two pieces. It equals this if, and when I need you to set that x minus 2 greater than or equal to 0. X minus 2 is greater than or equal to 0. And it equals this if the x minus 2 is, take a guess. Less than 0. Now, do you want to improve that? What's a better way to write that?
X is greater than or equal to 2.
Yeah, write that, Owen. You might find that easier. I just wanted to show you. I just went back in there and said what was in the bars, and I said that had to be greater than or equal to 0. And I went back in here and I said what's in the bars, I said that had to be less than 0. Cool? So if you want to improve this, what was this again? X is 2, the greater than or equal to symbol, and this is a what? Okay, but guess what the graph does? It was what we had before. Oh, line with positive slope. What was going on before too? Line with a what? Negative slope, right? It's a bad looking graph. Just so you can match it up. Just to make that connection. That was that side? This side? Right? We get it. So, we need to find a limit as x approaches 6. And then when this doesn't have a plus or a minus on it, does it? Let me make sure. Everyone, my eyesight's getting worse by the year. And all the other math textbooks I'm fine. Stewart, it's just, you know the font size? Sometimes I can't see it. So I just want to go back and double check he didn't have a little plus or negative on it, did he? This was number 42. I actually stole it from 2.3. I'm like, they should have put this problem in the last section. Nope, it looks clean to me. So this is number 42, is actually way up on page 107. Alright, there it is. Page 107, number 42. Well, I want to make this graph. Well, can you help me write this expression? What is this equal to? Well, this is equal to 2x plus 12 over x plus 6 if x plus 6 is greater than or equal to what? Is that what I heard? What's the other piece though? What's the other piece to that? 2x plus 12 over a negative x plus 6 if, and what goes here? Just look inside the bars. If the x plus 6 is what? Less than 0. So don't worry, some students come from a pure calc curriculum, they're like, I never saw this. I know, we had our course here, we actually included with a supplement. I was teaching it this right before your class at 6 p.m. I was teaching this. You know, we did about 4 examples of this, and you get it. So anyways, can you clean this up? Can you simplify that? I bet you can. Can you factor that in simplify? What can you factor out of that?
X plus
Yeah, factor out the 2, you get x plus 6 over x plus 6, and what does this simplify to be? Oh, this is just a 2! No one see that? Let me write in case people don't say that's a 2, that's an x plus 6, that's all over an x plus 6. Cancel it out. So what's this function? If x is, what's a better way to write this? That's another way to write that right there. The x plus 6 greater equals 0. X is greater equal to what? Negative 6. Yeah, I'll write that. So in here, let me just write this cleaner. We're saying this expression right here is just 2 if x is greater than or equal to a negative 6. But what's the other side? Can you clean it up? Oh yeah, what can you factor out of that? You factor out the 2, you got that little negative down there though. You get this x plus 6, you get this x plus 6. What cancels? So this equals this. So this is equal to this. So now it's equal to a negative 2 if what? This function is this graph if x is, well what does this say? X is less than what? So everyone take a guess, what does that graph look like? Now some of you might have hit on your graphing calculators. I thought we'd have fun doing it this way. So what do these graphs look like? Those aren't slanted lines, they're just what? They're just flat. So it's a flat line if x is greater than or equal to negative 6, and it's a 2. So right here, just go, and I closed the dot by the way, because it had an equal symbol. What's it doing if x is less than negative 2, or x is less than negative 6? What's it doing? What's the y value? The y value is always a what? A negative 2. So over here, now it's what? Flat that way. By the way, should I put an open circle here?
Yeah.
Yeah, I'm going to put an open circle on that because it didn't have an equal sign there. By the way, it's impossible to put a dot over a dot because that wouldn't be a function. Do you agree?
Yeah.
It'd fail the vertical line test. By the way, now we know the answer. Would you just look at this? Find the limit as x approaches 6. Look, I don't have a plus minus here, so it means from both sides. The only way this can work is if both sides are heading towards the same number. Is it? No. So what's the answer? What's the answer to that question right there? Done input? D and E. Y'all follow me?
Yeah. I have a question where it says f, or 2 if x is greater than or equal to negative 6. What if, I understand you gotta have the equal sign on one side, doesn't matter which.
No, great question. I love it. I love it. He goes, you're going to put the equals on one of these, right? And you're like, well, which side do I do it on? Well, I do this. But this problem, I like it because this originally had this set up. So I'll be honest, I actually just made a math error, and you kind of caught it. I'm looking back at the original problem. This is from the textbook. Everyone agree? Because that's the original expression. We all know the golden rule in mathematics. Denominators can never be what number?
0.
So no matter what, does this function, no matter what, because this was the original expression, does this function really exist at negative 6?
No.
So Evan, you know what I'm going to have to do? I'll have to tweak this. No problem, I'll still get the same answer. But I really should have an open circle there. Because, does everyone agree? There's no way this graph's function exists at x equals negative 6 because denominators can never be a what? 0. So I'll just take that off there. And thanks for spotting it, you know? But in other case, if it doesn't have a denominator down there, you just put that like that thing. You can put this on either side. It does not matter which side you put the equal sign. Cool. But I'm glad you spotted that when I had a little typo. We had to write that little annotation in the video. I was like, whoa.
I just had no clue.
It's great. Because, but you look at this, you go, this is the original setup of the problem. So we know in mathematics, no matter what, in any expression, the denominator at an exact point can't be 0 in the denominator, right? So that's how we know that nothing's existing at x equals negative 6. Right? You go, well, what if you simplified it? It wasn't simplified yet. That was the original expression. Now, would you try this on your calculators? I want to see how good they are. It only take a second. I was going to put it on the screen, but I was like, I'd rather you try it. How do you do it? Where's the ABS thing? Where's that ABS thing? Yeah, catalog. Go to catalog. It's the first thing on the list. You'd have to type y equals, and you go 2x plus 12, hit the division, and then you can do ABS, and it puts a parentheses, and then you put the parentheses to what? Now I have a type on the board. What should I put around the 2x plus 12? Yeah, there you go. But I want to see how good your calculators. Who has an 83? That's really what I'm curious about. I want to know if the 84 is better than the 83. Did it do it? Oh, good. So guys, it works. So you could. This is my point. If you're stumped on a test, you see something like that, you're like, wait a minute. I know how to do limits. I just need to look at the graph. I just need to look at the graph, if you're struggling with the algebra, pull out that graphing tool, is it working? But you can check it out. I was wondering if the 83 is just as good.
Yeah, it kind of worked.
Cool, it didn't do a funny goofy thing here, sometimes I was worried about that. Nice.
Calculator keeps saying dimension.
Oh, let me look.
Or something.
Yeah, mine's
Yeah,
connected,
let's just
so-
see. One,
Dimension
Well, I
mismatch.
didn't enter
That's
anything.
exact-
I just-
Oh, I'm gonna take that plot off.
Oh.
I'm glad you showed me that, you wouldn't be able to use it, now you're fine.
Okay.
I got
Now, let me check the bottom here, make sure there's nothing in there. Good, sometimes there's stuff down there. Now it's gonna work, just don't let that get highlighted, if it does, just unhighlight it.
I got this one.
Get the step plot on. We know that, don't let your graph when the step plot's on. Nice. You wanna do it? So all I'm gonna do is, I'm gonna do parentheses, I'm gonna do 2x plus 12, close the parentheses, divided by, now I need that ABS, don't I? It's in catalog, second zero.
Yes.
It's the first thing. Then you just do x plus 6. How's it look? Flat line, right? Cool.
Yeah.
I do that right there. I'm gonna do zoom so you see.
If you go to Zoom,
Nice.
6,
Nice looking graph.
standard zooming.
Did it work? Maybe I should have brought that thing, I could have showed it on there. Good. This is, everyone, it's a little noisy, you know? It's a little noisy, but that's okay, we'll show this graph. After this, we'll do a sine graph, let's see how good it is. Can you hear it? Click, 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 click. Thing's a little loud, isn't it? Alright. Hey, just to project this, let me just grab that machine from the other side and we'll put it on there. This is so if anybody in here didn't bring a copy, you just want to see it.